This video is on coordinate geometry, plane shapes. We're going to look at the properties of triangles and how they are marked with the different types of triangles. So we have types of triangles are scalene, isosceles, and equilateral. And these are based off of the sides of the triangle. Nothing to do with the angles, but this is about the sides. Then we also have acute, right, and obtuse. All three of these names are based off of the angle measurement of the triangles. So a scalene triangle has no congruent sides. So all three sides are different lengths. So if I were to draw this, my triangle would have three different side lengths. But if I'm just looking at this picture, I cannot tell that these are all different side lengths because there are no markings. That is why we have to show the markings on a plane shape. We are not in a coordinate grid, so we do not have the actual values. So we have to show the markings, the tick marks, to show that they are all different. So one of these sides will have one tick mark because that is one length. Now no other side will have the same amount of tick marks because they are not supposed to be congruent. So I'll make this second side have two tick marks. 1 and 2 are different sizes. And then the third side I'll have 3 tick marks. Because all three of these have different amounts of ticks, all three of these sides are different lengths. An isosceles triangle is when you have two congruent sides. You cannot have one congruent side because it has to be congruent to something. So we go from none to two. So picture of this, your normal isosceles looking triangle. In order to have two congruent sides, you have to have two sides have the same amount of tick marks. So if I put one tick mark on this left side of the triangle, I need to put one tick mark on another side. So I'll put one tick mark on the right-hand side. Both of those sides have one tick mark, therefore they are the same length. Now if you notice the third side, the bottom, I do not have any tick marks on. So it has 0 tick marks, which means that it's not the same as the other two sides. So it's still telling me that they are not the same. I do not have to put 2 tick marks on the bottom or any tick marks on the bottom to show that they are not the same size now. Because we've marked these two, then that means that these are the same and the third side has no markings, they're not the same. The next one for the side lengths is equilateral. An equilateral triangle is when you have all three sides are congruent. All three sides congruent. So equilateral means equilateral. Equal means same or equal. Lateral means sides. So equal sides. So all three sides in a triangle are equilateral, or all three sides in an equilateral triangle are congruent. So if again we were to draw this, we'd have our triangle. But to show that they are congruent, I have to have the same amount of tick marks on every single side. I would have one tick mark on the left, one tick mark on the right, and now I do have to put one tick mark on the bottom. That's the difference between isosceles and equilateral. An equilateral triangle is technically isosceles as well because isosceles says we have two congruent sides. And an equilateral triangle does in fact have two congruent sides. It has all three, but it does have the same properties as an isosceles. Now, an isosceles triangle is not equilateral because the isosceles only has two, where an equilateral says you have to have all three. So reading it down doesn't work, but reading it backwards or going up the column, you have the same properties. So all three sides are congruent. And again, you can also have 2 tick marks, 2 tick marks, and 2 tick marks. It all depends on what other markings you have, if it's easier to put 1 or 2 or even 3 tick marks on things. The next one we're going to look at is the type of triangles that have to deal with the angle measurements. So the first one we're going to look at is acute. An acute triangle has all angles so we're dealing with angles now instead of sides. All angles are less than 90 degrees. That's what acute means. So in a triangle, you can have one angle that's acute and another angle that's obtuse, but an acute triangle means all three angles are acute. So the shape of this would be the simplistic triangle shape that most people draw. As long as there is no markings on here, then we do not have any right angles. These are acute angles. They are smaller than 90, but they do form a triangle. All three of these angles would still add up to 180 degrees. Now, this actually, angles will relate back to the sides, which I will explain in a moment, but the amount of markings on an angle we can also do based off of the amount of tick marks we have as well. The next triangle we're going to look at is a right triangle. A right triangle actually only has one right angle, which a right angle is 90 degrees. Why can it only have one right angle and not 2 or 3? Is because a triangle is made up of 3 angles. If one of them is 90 degrees and a second one is 90 degrees, those added up are already 180 degrees, which means there's no room for a third angle. Therefore, it's not a triangle. So in order to have a right triangle, one angle is 90 degrees. The other 2 angles would have to add to be 90 degrees. Therefore, the other 2 angles are actually acute. So in a right triangle, you have generally a vertical line, a horizontal line, and then you have the hypotenuse. The hypotenuse is only in a right triangle. So in here, you have one right angle, and you mark that with that square to show that that is 90 degrees. These other 2 angles here would have to be acute in order for these 3 to add up to 180 degrees. And again, in a right triangle, when it's a right angle, the side opposite of that right angle, that is the hypotenuse. That's the only time we can utilize the word hypotenuse is in a right triangle. The last triangle we're going to look at is obtuse. In an obtuse triangle, again, only one angle is more than 90 degrees. For the same reason, for a right triangle, only one can be a right angle. In an obtuse triangle, only one can be bigger than 90. Because if I have one angle that's bigger than 90 and another angle that's bigger than 90, then those 2 angles together would be more than 180 and therefore would not form a triangle. So the way we would draw this would be generally an angle that is clearly larger than a right angle. So the right angle would have been vertical here, and I moved it to the left so it opened up more. But then I have that third side connecting it, and this is not called the hypotenuse because it's not a right triangle. I have one angle in here that is larger than 90 degrees. I'm just going to mark it to show that this arc, this angle here, I'm going to put a little arc on it, is showing that that angle is the obtuse angle. Now, I did say that there is a way to determine the amount of angles that would be congruent as well based off of the triangle. The amount of tick marks or the amount of congruent sides in a triangle only tells you how many congruent angles there will be. So in an acute triangle, we know that all 3 angles are smaller than 90 degrees. that could be 60, 60, 60 because all three angles add up to 180. But it could also be 20, 60, and 100 is going to be an obtuse triangle. So those tell you that those three angles are still different. Or it could be 50, 50, and 80. And we have two angles that are the same and one angle that's not the same. So it actually comes from the type of triangle with the side lengths. If you have a scalene triangle where you have three sides are all different, that actually tells you that all three angles have to be different as well. And again, this only works with a triangle. The smallest side in the triangle, so if I use this one tick mark, is pretend that this is the smallest side. Then the angle opposite it, I'm just going to draw this real quick. I'll erase it. The angle opposite this will actually be the smallest angle. And we can see that this angle is much smaller than the other angles around. Then we have, if we see these two tick marks on this side, if I go across the triangle to the angle opposite it, this angle would be the second biggest. So I would have two arcs to represent congruent angles. Because I have the smallest side goes with the smallest angle, the medium side goes with the medium angle, and then your largest side, which is three tick marks, goes with the largest angle. But again, it's across from it. It never actually touches it. So I would put three arcs on here as well. And we can see that this angle is clearly bigger than that first angle that I drew. So in a triangle only, the side opposite the smallest, or the angle opposite the smallest side is the smallest angle. The angle opposite the medium is the medium angle, and the angle opposite the largest is the largest angle. So that holds true with isosceles triangle as well. We have two tick marks on here, meaning, and they're the same size. So if I were to look at this isosceles triangle, I have a tick mark on the left. So if I go opposite, so to the angle that's not touching it, that corner that does not touch that side, this angle would have a one arc attached with it. And then the next tick, the other side that has a tick mark, one tick mark, go opposite of that. And I would have one arc on that angle as well. So an isosceles triangle has two congruent sides and two congruent angles. The angles and sides go hand in hand with each other. So an equilateral triangle, if all three sides are congruent, then all three angles are also congruent. And that's actually called equiangular. So equilateral means same sides. Equiangular means same angles. They actually go hand in hand every time. Again, only with a triangle. So if all three sides are the same, then all three angles must be the same. And that has to be 60 degrees, 60 degrees, and 60 degrees. So the amount of tick marks helps us to be able to put markings for our angles as well. And again, this only works within the same triangle, not from one triangle to another. So I cannot put this tick mark has an arc here against that angle. That angle is not the same as down here on the isosceles triangle. These two angles from different triangles are not the same. So it only works within the same triangle. Now the last thing we're going to look at for the triangles is the area of a triangle, because you do need to be able to find area and perimeter in coordinate geometry. So perimeter is adding up all the sides. So as long as you know all the lengths, you can find the perimeter. The area of a triangle is A equals 1/2 times base times height. So the B is the base of the triangle, and the height is the height of the triangle. H is the height. So the base is going to be generally a flat surface. You can turn it. The base is generally going to be the bottom. It doesn't have to be. But the height is going to be the vertical piece of the triangle. So you would want to turn one of your pieces of the triangle to have a horizontal aspect, and then you would use the height going straight up from the base. Some people like to use b times h or bh over 2. That's the same formula, it's the equivalent formulas. It's just saying 1 times base times height is base times height, and then it's all divided by 2 because multiplication is commutative.